In this tutorial, we'll look at Finite Impulse Response filters. We'll open MicroModeler DSP and click on the Designed Filters menu. We'll choose an equiripple filter designer from the toolbar at the top and drag it to the application. After you drop the filter, the displays will be automatically updated. With this filter, we can design almost any frequency response that we want. Using the magnitude frequency graph at the top right, we can use the control points to edit the shape of the response. We can move control points around. We can drag new control points from the menu bar to the graph. The del key deletes the selected control point, and we can also use the right-click menu to insert or delete control points. We can also adjust the length of the filter. A longer filter uses more CPU on the target processor, but gives a more accurate frequency response. For more precise control, the control point coordinates can be entered manually. We can also adjust the type of curve or line used to connect the points. FIR filters are not very good at handling sharp changes in frequency response. If we reduce the width of the transition band, ripple increases, which can be counter-reduced by increasing the filter length. You will find that when designing FIR filters, you will have to trade transition rate, ripple, and filter length with each other. If you look at the graph at the bottom right, you will see the impulse response of the filter. For FIR filters, the tap strengths and impulse response are the same and are known as the filter's coefficients. Everything we need to know about how the filter will behave can be determined from its impulse response. You can also design FIR filters in the same way using the frequency sampling designer. Sometimes there can be ringing where there are sharp edges in the desired response. This is known as the Gibbs phenomenon. You can specify a window function in the dialog to reduce the Gibbs phenomenon, which smooths the edges of the impulse response. There are a variety of window functions you can use. The easiest way is to experiment with them. Some of the window functions also have a window value, which provides additional control over its shape. Instead of using control points to define the frequency response, you can also drag a specification to your filter, which will automatically manage the frequency response and control points for you. Let's try dragging a low-pass specification to our design. If you go to the frequency response view, you can adjust the passband ripple, stopband ripple, passband edge, transition bandwidth. The specification will estimate the filter length for you, although you may want to fine-tune it afterwards. Now that we can design filters, the next step is to use them. The next tutorial will cover getting code and data out of MicroModeler DSP so that we can do something practical with it.